So we want to talk about solving inequalities, linear inequalities. So luckily, solving an inequality is basically just like solving an equation or something with an equal sign, right? But the only thing is it has one special rule. So when we're talking about inequalities, we're talking about things that deal with greater than, less than, greater than or equal to, less than or equal to. So one thing we need to note is that when we're comparing two numbers, so let's say 5 is greater than 2, um, this is currently a true statement. But one thing we're allowed to do in math is multiply both sides of an equation or an inequality by the same number. We're allowed to do that. In an equation, we don't have to do anything more than just multiply both sides by that number. But in an inequality, something else comes along. So what I'm going to do is I'm going to multiply both sides of this equation by a -1, inequality. And we're going to see what happens. So now that it becomes -5 on the left and -2 on the right. And I run into a problem because before it was a greater than symbol. Well, now I read the statement, I say, ooh, -5 is greater than -2. That's not true. -5 is not greater than -2. So by multiplying both sides by a negative value, I have changed the statement a little bit because where before 5 is greater than -2, now I multiply both sides by -1, and I need to now flip my sign because -5 is less than -2. So this happens every time we multiply or divide, because remember, division is just multiplying by the reciprocal. So every time we multiply or divide both sides, so key thing here, both sides of an inequality by a negative number, okay, we need to switch the inequality. And we can see why by just that simple example of what happens when we multiply by just a -1 on both sides. So every single time we need to go ahead and switch that. So here's a little short example. If we have -2x is less than or equal to 12. So we can think about how we might solve this if it was an equal to, right? Well, we would just divide both sides by -2 and we'd get x is equal to -6. But now we don't have an equal sign. Now we have a less than or equal to. But almost everything is the same except that one rule. So we just need to watch out for multiplying or dividing by negatives. So we're going to divide both sides by -2 just like if it was an equal sign. X is, divided by a negative. So alarm bells should be going off to go ahead and flip from a less than or equal to a greater than or equal to -6 for your final answer to that inequality. So let's try a couple examples here. One thing we're going to do is keep using graphing. We're going to keep graphing here. We're not just going to solve and let it go. We're going to solve and then graph. And we're just going to graph in approximates. Okay, so some of these answers might be decimals, and that's okay. You're just going to want to plot them as best as you can. So we're going to go through a few examples. We're not going to do quite all of these, but we're going to go through a few good ones here. Okay, so we're actually going to skip number 1. Now we'll do number 1. Okay, number 1. So again, think of this less than or equal to just as if it was an equal sign and ask yourself, what would you do first? Well, you'd subtract the 7 from both sides. Okay, 7 minus 7 is just 0. You're left with your 2x is less than or equal to. Remember, we're subtracting here, not multiplying or dividing, so we don't have to worry about flipping the sign. So this is less than or equal to 8. We would divide by 2. And that's a positive 2, so again, we don't have to worry about flipping the sign. 2 over 2 is just 1, so then we have x is less than or equal to 4, and we want to plot that. So we're going to go ahead and find 4. It's or equals 2, so it's a solid circle there, solid dot, and we're less than, so we're going to go off to the left. Okay, fractions work the same way. So if you see a fraction, don't be intimidated, just treat it like an integer. We have 4x minus 1/2 is less than -15/2. So we're just going to go ahead and add 1/2 to both sides. So that gives me 4x is less than negative 14 halves. Or if we simplify, that's 4x is less than negative 7. Okay. And we're going to divide both sides by 4 to get x is less than negative 7/4. We want to plot that. All right, and negative 7/4 is somewhere in between negative 2 and 1. This is a tiny enough graph, I don't have to worry about it too much, but I do need to make sure that it is an open circle because we can't be equal to, and then we're going off to the left there. Okay, so just make sure you're carefully following solving equation order. So we're going to do number 5 here. Keep in mind that if something is in a fraction, don't mess with that fraction until everything else is gone. So I'm going to make sure that I'm subtracting 9 from both sides first. We get 0. We're left with our x divided by negative 4 is greater than or equal to 11 minus 9 is 2. Okay, now that's a divided by negative 4, so we want to do the inverse operation, which is multiply. Now here's where our very special inequalities only rule comes in, which is if we're dividing or multiplying by a negative, we got to flip that sign. That's what a negative does. So negative 4 over negative 4 is 1. We have x is, flip it, less than or equal to negative 8. We'll go ahead and plot that right on here. So solid circle for that or equal to bit. We're going to make sure we're actually plotting it at negative 8, not positive 8. Here we go, right down there. And less than, so off to the left. Okay, last one we're going to do. Just like with equations, so equal signs, we want to make sure that we are simplifying both sides of an inequality before we try to solve it. That means distributing and combining like terms. So I'm going to go ahead and distribute 3x minus 12 plus 8 is greater than negative 10. And now I'm going to pause again. Can I still simplify? Yes, I can combine my like terms right here. So we're going to have 3x minus 4 is greater than negative 10. And we're going to keep going. So we'll add 4 to both sides. We get 0 here, so we're left with 3x is greater than negative 6. Divide by 3. We're dividing by a positive, so we don't have to worry about flipping. X is greater than negative 2. No equals 2, so that means an open circle greater than going off to the right.